Zachary Gallipo. I'm here with my teammates, Tyler Kaiser and Alexa Darsh, and we are Team Infineon. Today, we're going to be talking about the second generation Spec tester. The Spec system is designed to stress test voltage converters for reliability over time. This is to ensure the quality of the product. Each tower consists of 6 individual neighborhoods. Each neighborhood consists of 10 sites. That's total to 60 devices per tower. Each voltage converter runs under a high current load. This is assimilating years of use. With 60 devices running under a high current, this system gets very hot. So that means thermal regulation is going to be key for this project. Our goal was to create an interface that can control the onboard fan to regulate temperature and read back data. The current software being used is insufficient for both of these tasks. Once our interface is created, we can expand upon these features to other devices on board to increase both its functionality and control. This would remove reliance on third-party software and have significant cost savings for the company. At our current stage, we are expected to have an interface that can set the temperature limit of a site, as well as display information such as temperature and duty cycle. Our interface should also be easy to read and understand.
The first technical challenge we encountered was inter-device communication. Our solution incorporated many modules, each of which had to communicate using a different protocol. Zach, as the lead electrical engineer, was in charge of this stage of the project. The Spec tester, which houses the phase fan and controller, connects to the microcontroller, in this case, an Arduino Mega. The communication protocol used here was I2C, a form of serial communication that connects multiple devices on a single bus. The microcontroller connects to a system PC using a standard USB serial port, which the data processing engine can read from. The value is then inserted into a database to be displayed to the user in a graphical user interface. Once we had a flowchart of how the system works and how all the parts fit together, and had all the hardware working, it was my task to create a graphical user interface to connect the user to the end system. To improve current functionality, there were 3 main functions that our GUI had to have. The first function was the ability for the user to define the target temperature for each site individually. The temperature from the GUI was stored in a fan controller register, and a feedback loop was used to regulate the fan to maintain that temperature. As Zach said, the system runs very hot, and the current solution is to run the fans at 100% constant. Our solution is significantly more efficient and gives more control to the user. Secondly, the data needed to be read back from the test site to the user. We were using this functionality to read back the fan duty cycle and the current temperature to prove that the system was working as intended. In the future, this will incorporate more advanced testing results, as well as error messages and more. The final function was the ability for the user to define the interval at which the system reads. While the system can handle multiple reads per minute, it is certainly not optimized for it and is usually unnecessary. This system gives the user more control over how much data is being collected. The final technical accomplishment was our method for data processing. There will be significant amounts of data being passed from the Spec board to the user. Alexa developed most of the data management, developing an engine in a programming language, Python. We employed a modular design to optimize the system and accomplish each task individually. Communication between the Python and the GUI proved to be a bit of a challenge. To accomplish this, we employed a database structure that both the GUI and the Python can read to and write from. This led to a effective and efficient solution.
So as you can tell, we've made a ton of progress over the past couple months, but we're not quite at our best anticipated outcomes yet. To get there, we have a couple more challenges that we're going to have to overcome. The first one is expanding to multiple devices. This is going to be technically challenging because while we have communication set up with one site and it's working perfectly, the entire system has 60 sites with 10 neighborhoods and 6 Arduinos. This will involve a lot of debugging that we can't do with just the one site that we have right now. This is also going to be a little logistically challenging because the entire system is massive. Like, I have to stand on my tippy toes to reach the top. So we can't just pack it up and bring it to Schneider for testing on our own time. We have to drive to their office in Warwick to test on everything. Additionally, there's a limited time window when we can do this testing, which is when they turn the system off and back on again, which is only once a week. So we have a little logistical challenge and then also the debugging and actual technical work that we have to do. After that, we need to expand to the rest of the devices on the spec board. Right now we have communication set up with the fan controller, but there are other devices that we're going to have to talk to because they have very important information. So it will be technically challenging to set up those lines of communication. Additionally, there are some advanced calculations that we are going to have to do with the data that we get. These calculations right now are being done in MATLAB. This is mostly a matter of expanding our data processing. Python is an incredibly powerful language, but obviously porting something over from MATLAB, which is designed to be very user-friendly and math-oriented to a language that's a little bit less so, will be tricky. Lastly, we need some sort of fault management system. There are many things that can go wrong in our project that won't cause the entire program to fail, and we need to let our end user know that this error may have occurred. What we don't want to have happen is have everything run fine but then not work and send our end user on a very frustrating adventure to try and figure out what the problem is. So we need to have some sort of system to test at the end of the run to say, hey, everything went fine, or you might want to look here, something sketchy happened. This is very, very critical to our long-term usability of the system. And once we overcome all of these challenges, we will be at our best anticipated outcome, and that would not have happened without the support of these lovely people. So thank you so much.